I'm going to go back to this CarFactory. So we created this CarFactory class, and we have four methods in there to create different pieces of the car: the wheels, the engine, the paint. Um, and then outside of the class, we created a factory object. We used a factory object to create a car, an engine that's B4, paint that is red, and wheels, four wheels. And then using that car object we created from the factory, we assembled the car by setting the engine, the paint, and the wheels. And then we printed the car specs. So down here, if I go python.test, I get car, paint, wheels, etc. Um, we also built other classes for the paint, the engine, the wheels, and the car. So the paint class has this def init weird looking function is actually like a keyword function in Python that allows you. It's like what the constructor is. So if you remember
Hmm.
in C++, I was talking about a constructor. This is a constructor in Python, and within the constructor, I set a member variable. I created one and set it to 0 called paint, and then I set the paint, and I have an option to get the paint if I need to get it. So uh, when I create paint, I have a argument that's passed in called color, and I create the paint object, and then I set the paint, and then I return the color. Uh, which actually I should be returning the paint. I realize that I returned the color. That might be what Justin was talking about last week. I wonder if I broke anything when I did that. Yeah, I did. It's fine. We'll fix that later. So we return the paint. And then the next thing, a lot of these have setters and getters just for
Hmm.
completion's sake, is the engine. For an engine, we have an engine type, which is just the string. Create an engine, set the engine type. So we created this engine and we set the engine variable. And I set it to V4 in this case. So the engine set to V4. And then the wheels, we set the wheels. The wheels is just the number in our case. Now, in the car, it's a little bit different. We have to have the hooks to like basically assemble the full car.
Hmm.
So in this case, we set the frame, paint, engine, and wheels. Frame being like a car or a truck frame, etc. We have functions for making the frame because the car has to make the frame, car class, and then we get the frame. We set the paint. We can get the paint. We set the engine. We can get the engine. We set the wheels. We can get the wheels. And then I have this little function called get specs, which is just going to like basically return all the specs in a string.
Hmm.
And I have car, I have frame set as get frame. I have paint set as self.get paint. So it uses this function dot get paint. And this is where my error was. So this function gets the paint, but paint is an object, if you remember. So paint is an object off of this class. So if I want to actually get the paint, I have to use this function get paint. So this is where object oriented can get really long with strings, but self.getPaint returns the paint object, and then I do get paint. And then same with wheels. Wheels gets the object, and then get wheels gets the actual wheels. Engine gets the engine, then the engine gets the actual engine. And so if I go to my thing here, oh, get paint error, type one argument was given. I bet you I have a self. I forgot to put self here. Do it everywhere else. Yeah, I did. That just comes with experience. I knew what that error was. Almost anytime it says zero
Sure.
propositional arguments given, it's like a self error. Anyways, so now I can print the car. And if I wanted to do a different car, I could do the exact same steps. Um, and like let's say I wanted to create a truck. I could use the same factory. I don't need to create a new factory.
Mm-hmm.
I could make a truck, and I could make it a V6, and I could make it black, still four wheels. Boom. Now we have our nice little. Ooh, I have an
You're
error
just
here because
you're just
I
printing the
didn't print.
car.
Yeah, I forgot to print the second one. I forgot to set them too. I gotta set everything. Correct. Oops. Correct. And then print. So this is a factory that just lets you create a bunch of different things. Now, the key to the factory is that the factory builds the components for you, whether you have separate classes for the components or not, and you have to assemble the thing outside of the factory. That's what a factory really is. Now, a builder is what we're going to talk about next. Builder pattern. I'm going to comment out the print statements here. A builder is a class that uses a factory. And the difference between a builder and a factory is that a builder, you specify the features you want and it just builds it all together. It does self-assembly and just returns the full car, full truck. Whereas a factory, you kind of have to do it all kind of yourself. Lots of ways to build a builder. We'll go on the fly here and build something. Builder, CarBuilder. It's usually specified. And what you're usually doing is with the CarBuilder, you have a bunch of functions to set the features. So def, set, car, uh, vehicle type, itself. I'm going to do something. We're going to need some arguments. So I'm going to do it init, def, underscore, init, underscore, this. Click, and then self dot car type equals 0, self dot just do frame, semantically make it a little bit more clear. Set paint 0, self dot so we got paint, we got engine. Other than an engine, we have yes. Yes. Equals 0. So this time we're not returning anything, we're setting it. So we're going to self dot frame equals, and we'll say type. Semantically, frame type is a little bit more clear. And so you set the frame type, def set paint, self dot paint or color. Paint. Set dot or set engine. Kind of this type. Actually. I must type engineer a lot. All right, so engine equals engine, and then def that last thing is wheels. Wheels. Wheels equals wheels. And then def build is the last function. Build. Yeah. And what I might end up doing in the future would be like, I might make it a little more semantically clear and do vehicle builder and change all the classes because I really like to make things semantically clear. Or gives a certain implication. So what do I do now? I have a class that builds the vehicle. So I'm going to allow the user of the class basically to input all of the attributes into this function as arguments. They just have one function. I'm going to do I'm going to call a bunch of functions. Order frame type. Make sure that yeah. Clouds. Paint. Color. Stuff that. Set. Engine. Stuff that. Wheels. Alrighty. So we got all those set. And a build, when you build something, usually you return it. I'm going to say return, and I'm going to hold on. I need to do one more thing. Here. Frame is the thing that has everything else. So I'm going to do type. I need to do one more. It's self dot vehicle. Now the vehicle is the frame in this case. So now I need to do this fancy thing where I start to use the actual CarBuilder. Or CarFactory. And I can even cheat and use some of my code up here. I'm going to do the same thing. Do this fancy situation right here. So you're putting the build functions inside the class. So car factory equals car factory, car. You set the engine, wheels, frame, etc. Then you return the car. And we're going to change car to vehicle to be more semantically accurate here. We won't go back and change our other classes because it's a lot of work. Vehicle. Class. This is this. We'll do this. Semantically clear. We return the vehicle. Okay, so this is essentially what we would call that the features you want. Telling the builder what to do, just like building a house. Build components. Hashtag assemble vehicle. It's your turn. All right. So now if we go ahead.
The main difference between this one and the above one is that you just kind of put all the code that you put outside the class in a function within the class, and then you can just call that function as opposed to
100%.
Cool.
So we have a vehicle builder. Capital vehicle builder object, and then we have, say I want to make this cool truck. I'm going to do vehicle builder. Then I got to add in all my things. So we're going to make it, we're going to add car or truck. Yeah, frame type first truck. Make this one red. Make the engine V8 or a crazy truck. Wheels. We'll even make it a 6-wheel truck. All right. Now, print. Oh, and we have to do, sorry, we got to do build vehicle. And then we take our truck and we say get specs. There we go. Yeah. What's happening here in the terminal? Oh, shoot. No, it's not. I don't need to please be saved. All right, we're good to go. Feeding into the desktop real quick. Desktop. Python 3. And then we do test that. Thing is off because I forgot a self probably. Vehicle builder takes in one propositional argument. I did forget a self in the init function. So there it is. All right. So yeah. So you're spot on, Justin. Now we simply tell the builder what we want to build and it builds it.
Hey, quick question on
yep.
syntax, Ron. If you scroll up.
Yep.
So under the init, you set all of these things as 0, even though some of them are strings. Most of them are strings. But you're setting them as an int.
Yep.
I guess what are you doing here with the zeros?
So initialization.
So it doesn't matter what.
When I talk about declaration and defining, I'm not sure you can. This might throw an error in Python. Yeah, it throws an error. So you can't just declare in Python that something exists without defining the value.
Mm-hmm.
And so Python, I haven't gotten into types yet, which might be a good lesson next week to go on a deeper dive of types and to elaborate on the different types of languages. But Python's what's called duck typing. And basically the types are all dynamically calculated. And it only throws an error if you try to use a type incorrectly, like you try to add a character or a string, or you try to concatenate, which means put two strings together, two numbers. But it has a bunch of internal functions to try to figure it out as best it can. But if it can't figure it out, then there's a problem. Now, because it's dynamically typed, they really don't, and for some other reasons, they really don't allow you to just declare a variable. So in C++, I could actually do this thing where I'm just like, coming along and it looks like this. I would say, I want to create a variable that is like an int test that. And I haven't defined it at all. Now, if I use it before defining it, it's an error.
Mm-hmm.
But I could also do this and I could say, 0. But I could not do this. I could not say,
Nothing.
my string, because that's an error because it's statically typed. So there are basically 6 different combinatorics around types. The biggest one is statically typed languages and not statically typed languages. Statically types means you have to define the type when you define the variable, and you cannot assign it a different type. Dynamically typed, like Python, means you don't have to define the type. It's defined implicitly. And when I say define the type, I mean actually say the type, like string, etc. And then there's a couple other ones. There's manifestly typed versus non-manifestly typed. Manifestly means you explicitly say the type versus not explicitly say the type. This language, you don't explicitly say the type. Meaning you don't write it down, but it technically gets defined initially when you put it in. So this is currently defined as an int. and you can rotate it around the way Python looks at memory. So I could switch the memory addresses that would be for a type, or a 32-bit integer, or 16-bit integer, etc. There's a lot of flexibility in Python. And there's one more. I'm trying to remember where it is. I think it's like automatic cast versus not automatic cast. So in C++, you have to be explicit. If I wanted to change something from a string to a variable, I would have to automatically cast it, which means I'd probably have to do like, I'd probably have to do std string dot to string, and I would have to take the like my string, my like, or just a number, like a variable or a number, to like convert it to a string. There's functions to do this, but that is like literally in C++, you're specifying the memory transferring from an integer over into memory that is acceptable for a string. That's essentially what's happening. Python does all of that at runtime automatically. The downside is that you can run into errors where it can't do it, and you also don't control the memory, so it can have a really wild memory footprint and all this different stuff. I think that's a good probably lesson to go into next week, if you guys are interested in hearing the different types and getting some examples.
Yeah, sure. Thanks for talking me through that. So on the init then, could I set in Python, could I do self.frame equals, open quotation marks?
Yep.
Yep.
And this will work just as well.
Sweet. Okay.
Yep. And you could probably just do that too. That's an empty string.
Mm-hmm.
So you could do it to anything. I could even set it to another object if I really wanted to be like goofy with it, where I'm like paint or test equals paint, and then test as like it initially gets defined when the object is built as a test object. So you can do all kinds of stuff.
Okay.
In this case, we don't really care. So 0 is kind of the default value that people tend to use.
Sure.
I don't think there's a null in Python, but I'm going to check real quick. Null? No. There's like variables, and then in C++, there's a thing called a null operator, which basically says, I want you to set it to the first address in memory and the localized chunk of memory that's dedicated to the program. Memory will probably take more than one lesson to get into, because we have to talk a little bit about C++ and some other things, but it's worth getting into. There's like stacks and heaps, and it just gets like kind of more low level complex. This kind of abstracts all that away. From a design pattern standpoint, though, I think you guys got the basics of like what design patterns are. These are common ones. There's other ones we can talk through, but something to know. What was I going to say? Oh, this is a cast. This string right here is like a cast of the value, which I knew was a string, into a string. What happened here is, remember when I didn't have this? And I see this weird, like everything looks normal, and then I get to paint and it prints this out. It says paint at this random hexadecimal spot. That is like actually Python saying, coming up with a string value through the cast that says it is the object at this memory address, which is really interesting that Python does that. Whereas this one says resolve like the string at this address, and then it gives me back wheels. This for